So, before we add support in our application for navigation, let's understand how routing works in ASP.NET Core and ASP.NET Core MVC. Let us think about the traditional way of browsing to a page on a server. Basically, what happens is that you're making a request, for example, for index.html. The web server will search that file, and when found, that file will be sent back to the client. What's important to understand here is how the request is handled. A request is made for a file that physically exists on the disk, and when the requested file is found, that file will be returned to the client, so as the response of the server. Now, when we're working with ASP.NET Core and ASP.NET Core MVC, things are happening, well, differently. Remember that when using ASP.NET Core MVC, requests are handled by action methods on controllers. So when a request comes in, MVC will need to map the request to the correct action method on the correct controller. Although what is returned in the end is a view, a file with extension CS.html, the URL is effectively targeting an action method, not the CS.html file. There's no link anymore between the incoming request and a physical file in our application. The question then remains, how will ASP.NET Core MVC know which controller and which action to invoke? Well, the answer is a process called routing, and it comes with ASP.NET Core built in. Routing is a process that will map the incoming HTTP request to one of the endpoints of the application. That endpoint is responsible for producing a response by executing code, and that response will then be sent back to the client. Endpoints are configured at the startup of the application in the program.cs. Also, using the endpoint information, the application can generate URLs in the outgoing HTML, which can then map back to other endpoints. Here is a first very simple route. It's in fact the code that gets generated in the program.cs file when executing the template for a new ASP.NET Core empty project, and it already comes with some basic routing enabled. We're looking at the highlighted line here containing app.mapget. This code will, when an HTTP GET is sent to the root URL, execute the delegate. That in turn will send back hello world to the response. We've basically created a single endpoint using mapget. This will only work if a GET request is sent, not when another HTTP verb is sent to this URL. So using mapget, we're creating an endpoint. An endpoint, as the name gives away really, is something that will handle a request. A request comes in and a suitable endpoint is searched. And that endpoint can execute code to generate a response. An application will have one or more endpoints typically, and these are defined in the configuration of the application. Configuration code typically goes in the program.cs file. When a request comes in, an endpoint that will handle the request is also matched. Finding the most suitable endpoint is typically based on the URL of the request, but also headers, for example, in the incoming request can play a role. Once the matching endpoint is found, URL values on the incoming request will also be available for the endpoint. In other words, if a query parameter is included, such as the PyID we want to view the details from, that will be passed on to the executing endpoint. This way, we get access to the query parameter in our code too, as we'll soon see. Having the routing system work for us is again based on middleware. In fact, there are two middleware components which are responsible for this, and we can add these through the use of two methods, useRouting and useEndpoints. UseRouting brings in route matching capability to the pipeline. It will match the incoming request with an endpoint. We will look at this matching in just a bit. useEndpoints is responsible for adding endpoint execution. Now we typically in fact don't even need to add these two methods manually in the pipeline anymore. Since they are needed in pretty much every application, ASP.NET Core will apply them in any case. Your pipeline is pretty much wrapped, let's say, in a call to useRouting and useEndpoints. Routing is an ASP.NET Core feature. Now we are creating at this point an ASP.NET Core MVC application, and thus we will need to be able to map an incoming request, so based on the URL, to an action on a controller, so that that action can then execute and return a view. That matching will happen for ASP.NET Core MVC based on a template. We will, in our program.cs, define one or more route templates. based on the URL of the incoming request, a match will be searched, and that will result in an action on the controller to be invoked. As already mentioned, outgoing links also need to be generated, so that when the user clicks in their browser, they will navigate to the correct URL again. Generating these outgoing links correctly is also done using the routes we will define in the program.cs. For the MVC-based approach, there are basically two ways of performing the routing. In ASP.NET Core MVC, we will often default to what is known as convention-based routing. This should be the default when using controllers and views, like what we are doing here. When we build an API based also on the MVC approach, we should look at attribute-based routing. We'll see the latter one later when we add an API to our application. Let us now look at convention-based routing next. Routing is based on routes, and that may seem like a logical thing. Each route is a URL pattern, and that's mapped to an endpoint. In the case of MVC, this is the action on the controller. The fact that we can use patterns for our routes means that we don't have to type all the possible routes for our application. What will happen is that the URL of an incoming request is compared with these patterns. And when a match is found, in fact, I should say when the first match is found, that pattern will then be used to trigger the corresponding action. Take a look at this basic route here, bethanyspyshop.com/py/list. When we look at this URL, we can see that it's made up out of a number of parts. The host, www.bethanyspyshop.com, as well as py and list. And these parts are known as segments. Typically, the first part will point to the controller and the second part to the action. Of course, we have to explain this somehow to the routing engine. It is not something that works by default. We'll have to create a route that says that when a URL with a pattern with two segments is encountered, that will assume that the first one is the controller and the second one is the action. You can see the pattern that we want to use here, controller/action. And defining that route is then done using the map controller route inside of the program.cs. So the above request to py/list will therefore be handled by the list action on the py controller. As you can see, this action doesn't require any extra parameters. Now sometimes though, we'll need more segments in this route. Imagine that we want to view the details of a py with ID 1. The request URL for this could be py_details/1, and now the last segment is new. We'll now need an extra segment in the route pattern, as you can see here. The ID segment has now been added. Now that request we just saw can be handled by the action you see here. The details action now has an ID parameter, and by adding the extra segment, it is now possible to get this value into the method parameter. Now the template controller/action/ID is a very common one to use. It is in fact so common in ASP.NET Core MVC applications that a utility method exists, namely map default controller route. So if this template is the only one you need in your application, you can use this method here. In our application, this will do, but know that in many real-life applications, multiple templates will often be required, and thus we'll need to add them manually.